screen. I think, Tim, if you want, you can hit the recording again. Okay. And let me close this one. And there it is, but that's completely at the end. So let me quickly do this one. So, hello everyone, and welcome to the second session of the evening. Our session is titled Azure Private Link and Azure Private Endpoint. What's so private about it? On the agenda, and for your eyes only, first of all, we're going to talk about Azure Private Endpoint and Azure Private Link. We'll tell you all about what it is and what you can do with it. And of course, we'll show some demos in between. Then Micha will look into Azure Private Link service and also into the pricing, because yeah, at the end of the month, someone still needs to pay the Azure bill. And then I will talk about how you can use Cloud Shell into a VNet. Completely at the end of the session, we also go through the key takeaways, where we will focus on the things we think you should really remember about our session. And totally at the end, we probably will still have some time for a Q&A, where we would love to answer any of your questions.
Yeah, so good evening. My name is Micha Wets. I'm a independent contractor. I have my company called Cloud Architect. I'm also a technology strategist at Aspects, which is my day job, and next to that also WVD solution architect at NXP. So quite busy these days. Really proud member of MC2MC, and I became MVP in 2018, the end of 2018, on Windows Virtual Desktop. We also have the Twitter handle, the website, and LinkedIn. Also awesome QR codes where you can quickly snap and go to the LinkedIn page. Yeah, that's all about me.
So, okay, let me also shortly introduce myself for the people who don't know me. My name is Wim Matthijssen. I live in Belgium, where I work as an Azure technical advisor. I'm also a Microsoft certified trainer and an Azure MVP. And next to that, I'm also a founding board member, a proud founding board member of MC2MC. I also have my own blog, https://wimmatthijssen.com. And yeah, just like Micha and like most IT professionals these days, I'm also on Twitter and LinkedIn. So if you ever want to reach out, say hi, or have a question about Azure Private Link, for example, you can always contact me through my Twitter handle or yeah, through the nice QR code at the bottom of the screen. So Micha, I think it's now time we can start off with the first topic. So I would say go ahead.
Yes, let me share my screen. So the first topic is Azure Private Endpoint. We start with the beginning. Azure Private Endpoint. Come on. Okay, so what is Azure Private Endpoint exactly? It is a network interface. So like every virtual machine has a disk, but also a NIC, a network interface. The same with Private Endpoint. So it is a private network interface that connects you privately and securely to a service powered by Azure Private Link. Before we dive into the private link, let's first look at what a private endpoint is. So as you can see in the diagram at the bottom, it is a interface. It is a endpoint that gets into your VNet. It gives you a private IP address inside your VNet, which you can control, and it brings a service into your virtual network. So it is a connection between your virtual network and a other service. This service can be a PaaS service like Azure Storage, like Azure Cosmos DB, SQL, Key Vault, backup, so much more. And it brings that service into your VNet, so it makes it available in your VNet using a private IP address. So no longer a public IP or a IP from Microsoft. No, it's really a private IP address inside your own virtual network. But before we can do anything, before we can start, we need to prep our subnet, because there's a thing that you need to know about private endpoints, that it does not support network policies like network security groups. So you need to disable a specific setting in your subnet. It is called, and as you can see right over here, it is called Private Endpoint Network Policies. And this needs to be disabled on the subnet where you want to include your private endpoint. Doesn't need to be excluded in every subnet. It can be only the subnets where you want to integrate your private endpoint, but it needs to be disabled before you can even start using private endpoints. If you deploy a private endpoint using the Azure portal, then as you can see in the deployment, the Azure portal first disables it for you using an ARM template before it deploys the private endpoint. If you do it using ARM or using PowerShell scripts or CLI, you have to do it manually. So you have to do it yourself. As you can see here at the bottom, it's really easy. You first get your virtual network interface, your virtual network. You select your subnets over here. We do a filter here from default, so the default subnet only, and we set our private endpoint network policies to disabled, because by default it's enabled, and then we just update it. And as soon as you have configured this, then you're good to go and you can start using private endpoints in that particular subnet. If you want to use it in different subnets, don't forget to update there as well. After that, it happens more often than you think. You have your private endpoint inside your VNet, but it's not finished then, because yeah, you have your private IP address, but your VNet doesn't know about that private IP yet, or your virtual machines or anything running inside your VNet doesn't know yet about that private IP. It's there, but you have to use it. So if you want to connect to that particular service, you want to use FQDN. And if you want to use FQDN, you need to update your DNS zone, of course. If you want to do this, and I also added a screenshot over here, if you want to do this in a Windows environment, if you have your own domain controller, or if you're using Azure AD domain services, you have to create a primary DNS zone, which is called private link.filecorewindows.net, like you can see right over here. And you simply add an additional A record pointing to that particular private IP address. This means that all VMs running inside your domain are now able to use that private IP and the FQDN that you want to use. And also possible if you use private DNS zone, so it's not limited only to Windows, also possible to do that in a private DNS zone, which will also be shown in the third demo. If you use private DNS zone, simply add it to private DNS zone and it can be used inside your private DNS. So it's not only limited to Windows, also in the PaaS service from Azure. Enough talking. To show you how a private endpoint works, I did a quick demo, which is easy to deploy, but also can be quickly used. So I have a storage account with a file share, and I want to use this inside my Windows environment. So I created a private endpoint and linked it to my Windows environment. Let me jump into this one. So right over here, I have my storage account. My storage account, it's a standard storage account, really doesn't matter. But as you can see, it is domain joined. So it is joined into my Active Directory. And as we go to networking, you will see that it is not accessible from all networks, only from selected networks. I don't want to have this storage account available from everywhere, only the selected networks, the selected VNets, including my demo VNet, including the subnets. And it also has a private endpoint. So at the top, the default tab is firewalls and virtual networks, but you also have your private endpoint connections. Right over here, you can simply add a private endpoint. And if you do it like this, you click on create private endpoint, get to the wizard, then the portal does the subnet actions for you, so you don't have to worry about this one. But as you can see over here, already created a private endpoint. If we look at our resource group, so we have our storage account. The Azure portal will then create for you a private endpoint. Private endpoint, like you can see over here. And as I said before, it creates a network interface. So really network interface like you have on a virtual machine. And this network interface, if you go to IP configuration, then you can see it indeed has a private IP address, which is dynamic inside your virtual network. So inside the subnet that you select during the creation of the private endpoint, you get a private IP leased from your IP ranges. Now, this means that my storage account has my private endpoint, only accessible from within my VNet. So if we go to my Windows environment, as you can see, I created that primary DNS zone. I added my A record pointing to my private IP address. And if we now do an NS lookup, okay, we get that private IP address back from our domain controller because it knows the primary DNS zone. It translated to the correct private IP address. And if we would go to my storage account, I am capable of going into that storage account, even though it has a private IP, but there's no virtual machine behind it. It's really my storage account, and it's directly accessible from within my Windows environment. If I would do the same from an external virtual network, which is not allowed or is not using the private endpoint, I would not be able to use this storage account. So it is really attached and only available inside my virtual network. Okay, Wim, next is up to you.
So let me take control again. Okay, here we go. I think my screen is sharing at the moment again. So thank you, Misha, for the nice demo. So after that demo, we now wanted to look into Azure Private Link. Okay. So first of all, what is Azure Private Link? If you look at the definition, you can say Azure Private Link provides private connectivity from a virtual network, a VNet, to Azure PaaS, customer-owned or Microsoft partner services. If you look a little bit deeper, you can say that Azure Private Link, which is a relative new functionality in Azure, allows you to create a private endpoint in your virtual network, like Micha already explained, and enables you, by using that private endpoint, to access selected Azure PaaS service, like, for example, Azure Storage or an Azure SQL database, or even Azure Backup, by providing an internal IP or IPs for that specific PaaS service. It can not only be used for Azure PaaS services, but also to securely and privately access other Azure partner services or even customer-owned services, even if they're running in different tenants. And traffic between your virtual network and the service itself only travels over the Microsoft backbone network. So exposing your service to the public internet to make it available is no longer necessary. So why would you use Azure Private Link? Well, first of all, and like I already said, to be able to privately access PaaS services on the Azure platform by providing you a private IP to reference your PaaS services. It will also allow access from both peered virtual networks or they're regional or global, it doesn't matter. And also from on-premises resources, which are connected to ExpressRoute or a VPN. Next to that, it will also protect your Azure services against any form of data leakage. And last but not least, it will allow you to deliver your services directly to any of your customers, and this on a global scale. So before Azure Private Link, you could access your PaaS services such as like I already said, Azure Storage or SQL databases, which live outside of your VNet only via their public interface. You had then the possibility to secure this connection by using VNet service endpoints, which kept the traffic also within the Microsoft backbone network. But then the PaaS service used a public IP address, and therefore you couldn't access it from any on-premise resources through a VPN gateway or through ExpressRoute. And that's now where Azure Private Link comes in play. With Private Link, you simply create a private endpoint in your VNet and map it to the PaaS service. And since those PaaS services are mapped to a private IP address in the VNet, you're now able to access all those resources from through an ExpressRoute or through ExpressRoute private peering or through a VPN. And this effectively means that the data will traverse a fully private path from on-prem to Azure. So like you can see on the slide, connectivity works from on-premises, from branch offices, and even other clouds. And of course, it works in the VNet itself or from any peered VNet, regional or global. Once again, because Azure Private Link maps a specific resource to a private IP address, any malicious intent to exfiltrate data to a different account using the same private endpoint will fail. So in the event of any kind of security incident within your network, only the mapped resource itself would be accessible, and users' access is really restricted to a specific resource, which can be a database or a storage account or any other PaaS service, and not to the complete service. So in that way, you kind of have complete control over data egress, and you're protected against any form of data leakage. Private Link also works between services and VNets across different tenants and even regions. As an example, let us say you have a consumer's VNet, which is located in West Europe, but through the use of an Azure Private Link, they can connect to a service provider's PaaS service located, for example, in the East US region, and this without even affecting any performance or loss or latency. So currently there are a bunch of PaaS services which can be used in combination with Private Link, and you should know that Microsoft is still working on expanding this list with adding more and more services, focusing on those most critical in customer environments. At the moment, like you can see on the slide, you can use Private Link with Azure Files, Azure Storage, Azure SQL databases, Azure Key Vault, Azure Backup, and to name some. And you can always check all other supported ones through the link at the bottom of the slide. And one nice thing we also want to mention is that Azure Private Link can solve the overlapping IP address space problem. Like probably most of you know, traditionally we use VNet peering as a mechanism to connect multiple VNets. But VNet requires the VNets to have non-overlapping address spaces. But yeah, however, in enterprise scenarios, you often find networks with those overlapping IP address spaces. But now with Azure Private Link, you also have the possibility to privately connect applications in different VNets that have overlapping IP address spaces. So in this way, this problem is solved. So you should definitely keep that one in mind whenever you're architecting a new greenfield or even brownfield Azure environments, because I think in some ways and with some applications, it can really save your day. So let me also demo something. Let me close this one. So you're probably all seeing my Azure portal now at the moment. A thing we also want to mention is whenever you enable private link for specific resources, you should keep in mind that they can assume a lot of IP addresses in your subnet. So for example, if you go to my recovery services folder, let me type it in. So you can see at the moment, if it opens, that I have 3 recovery services folders. At the bottom one, the third one, I enabled a private endpoint connection. You should do this whenever you're backing up Azure SQL inside of Azure VMs, or whenever you're backing up SAP HANA inside Azure VMs, because this will better protect the way the agent is communicating. Otherwise, it still go to a service endpoint. And now with connecting the private endpoint, you will also using private IPs. But the bottom thing is, the thing we want to mention is, if you now go to the virtual networks, and I go to my production network, and I go to, and you see, this one is all in use by Azure Backup for the private endpoint, and it's using, if you count them, 11 IP addresses. So if you're not sized your subnets quite well, it could be that this is not going to work, because some past service will really get a grip on your IP addresses. So it's a good idea to maybe, if you design from the beginning, to foresee an extra subnet solely to store those IP addresses used by private endpoints. You can see also F1 for a key vault, and also F1 for a storage account, but they're all using one. But for example, if you have some special replications like ERA-GRS in some specific pass service, it can also be that instead of 1, it starts using 4, because it needs to be able to connect to different regions. So definitely keep that one in mind. Another thing we want to show is, let me say, I have 2 different environments. I have a consumer environment, this one, for example. In there, I have a VNet configured, I have some VMs running, and for example, I have a service provider, and I want to use a specific key vault from that service provider. So my environment is in tenant A, and the service provider's environment is in tenant B. But I want to connect to from my VMs, for example, to some secrets inside the key vault. That's also possible. So the thing you need to do is in the consumers. So this is my service provider, for example, and here's my consumer environment. So the thing you need to do is type in private link. This will open the private link center. Then you click on the private endpoints button. You click on add. It will open. You choose a specific resource group. I have a demo one for this. You give a name to that private endpoint. Let me say demo MC2MC, for example. It's located in, MC3MC, it's not, it's MC2MC, sorry. Just click on next. You see, you now have 2 options. You can connect to past services in your directory, or you can connect through them through a resource ID. You choose that one, and then you go to your service provider environment. You type in the key vault which you want to connect to. Otherwise, if it's between a consumer and a service provider, yeah, one needs to deliver all those specific settings to the other one, so the other one can connect to it. I click on my key vault. I go to the properties. I copy that specific resource ID. I go back to my other environment. I type that one in. I type in the sub resource for a key vault. It's vault. Please approve this. I type in a question. I go to next configuration. It's selecting my subnets, for example. Let me choose this one. Okay. Next to tags, you can type in any tags you want. For example, let me say demo. Okay. Next, review and create. You click on create. You can see it's doing some things in the back. Let us wait for it for a moment. Normally, it wouldn't take a time. The thing it's now doing, it's a two-way step verification. So this environment is asking approval on the other environment, which over there needs to be approved by someone who has owner rights or contributor rights on that specific resource. But let me go back to the other environment. Let me also go to private link. Let me do it from here. And normally you can see there is now a pending connection over here. So I'm an owner of this resource. I just can click on it, click on approve. Please approve this. I click yes, and normally it will be approved. It will probably take some time. And when it's approved, yeah, the resources from the one environment can use a key vault in the other environment. So let us wait first. So it's successfully approved at the moment. So now they can communicate even between different tenants, consumer one or service provider one, or even if you're using two different tenants in your environment, maybe you have a POC tenant and you have a production tenant where you use your production subscriptions, you can combine resources between those. So Mika, I think it's up to you again for the next one.
Yes. Let me share my screen. Okay, so the next topic is the Azure Private Link Service. As we already said, we have our Azure Private Endpoint, we have our Azure Private Link. We can go a step further and create our own Azure Private Link Service. Azure Private Link Service is a service that you own, and that is completely powered by Azure Private Link. That's the definition from Microsoft. But let's look at what it is exactly. So you have your own service. This could be a virtual machine. This could be any other service that you have inside your own subscription, inside your own VNet. In front of that, you put in a standard load balancer. So it cannot be a basic one. It needs to be a standard load balancer. And then you can enable and put the Azure Private Link service in front of it. Important to keep in mind, if you want to use the Azure Private Link, you set up a standard load balancer in Azure. It needs to have a front-end IP, which can be, again, a private IP inside your VNet. No public IP, private IP. So it can be an internal load balancer. Don't forget to set up your backend pools and your help probes, and of course your rules, because those are required for the private link to be able to access your service. So you set up a load balancer, you deploy the Azure Private Link service, and then your consumers, which are the users that will use your own service, they will be creating a private endpoint inside their own virtual network. So inside their own VNet, they create the private endpoint, and they will connect using Azure Private Link to your Azure Private Link service. The same way as we did with the storage account, or as Wim showed, we will be using a private IP address inside the virtual network from our consumers. And then again, like Wim said, that private endpoint and that service can be used by virtual machines or resources inside the VNet, but it can be also consumed from in the on-prem environment or from peered virtual networks. So it all comes together, and it's all capable of using a service that you provide to your customers. How to access that private link? So this is the flow that you want to keep in mind. First, you want to share the service, of course. I will show this in the portal as well. As soon as you share it, you get a moniker, as Microsoft called it, or an alias, which is more easier. You can also use the resource URI, but alias is easier. It's more readable. It's always unique. So every private link service gets a unique alias available. You give this alias to your consumers, and you can also control how the service is exposed using the private link service. You have 3 levels. First one is private. Private means that the private link service will only be available inside your own VNet. So it's not available for all consumers. It's only available inside your own environment, inside your own VNet, which you'll specify. Restricted means that you can determine which subscriptions can consume your Azure Private Link service. So if you want to filter out incoming requests, you can go for restricted and only allow specific customers to connect to your private link service. If you go for public, that means that all Azure subscriptions can connect to your environment. They can all use your alias. It's hard to guess such an alias, so you're not directly exposed. And it's like the link setup, like Wim showed, you still need to have the approval request. So the consumer, he will deploy a private endpoint using your alias. He will request access. You as a service provider, you will see this request coming up in your private link center. You can accept or deny it, and the consumer can then start using the private link to connect to your service. It is possible to set up auto approval. It's all documented, so that's perfectly possible. If you have a service that you want to expose to the internet and you want to have auto approval, it's perfectly possible. There's another level if you want to do some magic with nothing as well. That's also possible to enable, but that would go too far for this session alone. Comparable to the private endpoint, we need again a connection or a configuration on the subnet level. So no network policies are capable of working with the private link service. There's a different policy that you need to disable, which is called the private link service network policies. The same as we have with endpoint. If you do it using the portal, if you deploy the private link service, it gets disabled automatically. If you create it using IAM PowerShell with CLI, then you have to do it manually. And again, a demo or an example from the PowerShell commandlets. Again, enough talking. Let's dive into this. I have two environments. So the environment on the left is my consumer. The one on the right is my service provider. So the service provider, I started with a simple VNet. That was my baseline, a VNet. If we look into this, it's really basic. It only has one subnet, really easy, 10.3.0.0 subnet. And we also connected a private DNS zone to it. So if we want to have DNS capabilities, then we have a private DNS zone. As soon as we have this, I deployed a load balancer. So a standard load balancer with, which is a internal load balancer. So as you can see, private IP address that will be used. Again, with backend pools, help probes, and load balancing rules configured. And I also deployed a virtual machine. My virtual machine, as you can see over here, it has no public IP, so it's not accessible from the internet. It's only connected to the VNet using a private IP address. So my ES server, my web server, is running on the 10.3.0.4 IP address. After I configured everything on my ES server is running the web service, the awesome web service, as you will see. My load balancer is all set up. My VNet is ready. Then we can start creating a private link service. How do you do that? At the top, you search for private link. If you go to private link, you end up in the private link center, as Wim showed. And you can see private link services. And then you click on add and you go to the wizard, which will ask all those topics that I mentioned before, like the load balancer, like the VNet that you want to use, like the limiting of your service, private, internal or public. All those configurations, you simply go through it. And after that, you end up with your private link service. As you can see at the top, we get our alias. So the alias that we can communicate to our consumers. As you can see, it's hard to guess because it always contains a GUID. It also contains the name from our private link service and also includes the Azure.private link service URL and also the region that we are using it in. This one is deployed to West Europe, so the URL contains West Europe. You can also see which private endpoints are already connected. If you don't have any customers, then you will see no private endpoint connections, of course. Also, if a customer is requesting access, you will see it right over here. Then it stays in the awaiting connection state and also a description. That configuration, let's not dive into this. That would take too much time. But after we set up our private link service, that means that our web server is now exposed to my private link service, but not to the internet. So if a end customer wants to use it, they need to go to the wizard, of course. This is my consumer endpoint, my consumer portal. So I have my virtual machine running. This one has a public IP because I want to connect to it, of course. Virtual network and a private DNS zone. And I already created my private endpoint. And that private endpoint is connected to this private link service. Now, if we look at this virtual machine, then you can see that the two virtual machines have the same private IP address. Like Wim said, private link is the ideal solution if you have virtual networks with the same IP ranges. Using the private link, I will still be able to access this server, even though we are in the same IP range. So this is my virtual machine. As you can see, it has the private IP. What I did is create the private endpoint with a private IP 10.3.0.5. And what I did is add this one to my private DNS zone. So the private DNS zone, I added a record pointing to this particular service using the internal IP address, so the private IP. So if we would do a DNS lookup, then you see that I get a internal IP address back. And if I visit that URL, this website is not running on my virtual machine. It's not even running inside my virtual network. It is the virtual machine running inside my service right over here. So this website that you see is indeed connected and is using this virtual machine at the backend. So even though we're still in the same IP range, I'm still able to access the virtual machine right over there. And I think, Wim, it's back up to you.
Yep. And I think you forgot about our previous session about Azure Bastion, I think. With your public IPs. Just to mention. So I hope everyone is seeing my screen again. Let me take that one. Okay. Before going through my key takeaways, we want to talk about our last topic, how you can use a Cloud Shell into an Azure virtual network. So, like most of you probably already know, is that a regular Cloud Shell runs inside a container in a Microsoft network, which is separated from all your other Azure resources. This means that the commands you run from inside that container cannot access resources that can only be accessed from that specific VNet. For example, you were able to connect to your Azure VMs with a public IP address, what's best not in a production environment, but you were not able to connect them through Cloud Shell through their private IP address. But with the latest Cloud Shell update, you can now connect your Azure Cloud Shell to a VNet. And in the back, it's also using a private endpoint. With this new method, it will allow you to use PowerShell remoting, SSH, or any other command line tools you're using to connect to your resources over their private IP address. Before you can use it in this way, some resources need to be in place. The most logic one, first of all, you need a VNet. This can also be a VNet that is paired with your VNet. So if you're working in the hub-spoke model, it's best to connect the Cloud Shell in the back to the hub VNet. You also need a specific subnet in that specific VNet, and this to host a Cloud Shell containers. You also need a network profile, which simply said is a network configuration template that specifies certain network properties for the resources. And then you also need an Azure Relay. An Azure Relay allows two endpoints that are not directly reachable to communicate with each other. In this specific scenario, in the Cloud Shell, it allows the administrator's browser to communicate with the container in the private network. And the last resource you need is a storage account with the files there to store your files. But yeah, that's the same as before. There are also some key considerations and limitations you need to be aware of. Since private Cloud Shell is a preview feature, it's currently only supported in the West US and West Central US region. And because it's in preview, we would advise don't use it in any of your Azure production subscriptions. Some other things to keep in mind is that the use of an Azure Relay adds additional costs because it's not a free service to use. So if you spin up that one, at the end of the month, your Azure bill will go slightly up. Also know that starting up Cloud Shell in a VNet, in this specific combination, will slow down the startup speed of the Cloud Shell containers. So it will be slower than your regular Cloud Shell to startup experience. And to get this working, the Microsoft Container Instances resource provider needs to be registered, and this in the Azure subscription that holds the VNet that you want to use. And one other thing to mention is if you are already using Cloud Shell in any of your subscription or in your specific subscription you use, you first need to unmount the existing cloud drive to get this new experience working. Therefore, you can you open up your Cloud Shell and then you simply run the command cloud drive unmount or dismount cloud drive, I think it is, from inside the Cloud Shell, and then you will be able to reconfigure it. Let me quickly show this. So I have a specific resource group created.
Wim, I think you're on mute. Is it possible? It's back. I think I'm back, but Wim is not back.
Still online, but can't hear him.
Yeah.
Same thing. I can hear him talking. I can see him talking, but can't hear anything except Misha.
I will try to do some lip reading.
You can translate in real time.
I will, now that Wim is fixing his audio, I forgot one slide. I forgot the pricing slide. Let me quickly show this because it's sometimes quite important. So the pricing regarding private endpoint, private link service, as stated on the Microsoft site, private link service is free, so you don't get charged for the private link service, but you get charged for private endpoint. So private endpoint is a fixed price, no matter if you send any data across it. So it's 0.009 euros per hour. And then also inbound and outbound data that is being processed gets the same price. So if you think about the storage account, we did the example of the storage account. Writing to a storage account is outbound data that is being processed because your VNet gets outbound data to that specific storage account. And if you read from that storage account, it's inbound data that is being processed. So then you get billed for any inbound data that's being sent over the private endpoint. But you, as a service provider, you don't get any charges for the private link service. Keep in mind, this is on top of the data transfer. So this does not include data transfer. So you also have to keep in mind that if you have data transfer or bandwidth usage, this is not included inside this price. So this is on top of that one. I don't know if Wim is back. Wim, can you? I see Wim is not back yet. So let's jump to the key takeaways. Key takeaways. Use private endpoints instead of service points, service endpoints like public IP address, things like that. It's more ideal to use private endpoints because then you can use a private IP address instead of any public IP address. Use the private link to access past services inside your VNet because it has so many advantages, like you can really specify who can read or access a SQL database, for example. So instead of using any service endpoints, really go for the private link service. Private link, enable it for your own services. So you can even use the private link in combination with the private link service. And keep an eye on your IP addresses, which is really, really important. And I think we are at the Q&A, 6 minutes over, over our time. I don't know if there are any questions.
Just to say, I love the feature.
Yeah, rather than typing it, why do the network service group needs to be disabled? Is there a reason for that?
So why the network service groups, the NSGs need to be disabled?
Yes.
Or
to be able to use the service points.
You don't really need to disable your NSGs. So the NSGs are still applied to your subnet. It just doesn't get applied to the private endpoint or to the private link service.
Okay. So you have to enable the service on your NSGs, but your NSGs remain in place.
Yes, they will still apply to.
Except for the private endpoints.
Yes.
Okay.
So I'm back.
Aha.
Hey.
My device completely froze. I couldn't do anything anymore, and my other device wasn't reacting, so I completely needed to reboot, and then I need to do 2 reboots. So my excuses. You went through the last slides, I think.
Yeah, I already jumped to the key takeaways already, sorry.
Okay, yeah. Do you also answer the question from Jeroen, Micha?
I was looking at the chat.
That was the only one. I do have one generic question. It seems like private endpoint, private link is the best thing to do, but just as a simple statement, when it's not really necessary, worth the effort. It all depends. For security reasons, we would advise to use it because previously everyone was using the service endpoints, but that's still with a public IP address in the back. So if you really want to do it secured and with private IP addresses, you definitely don't need to do it for every PaaS service you have, but if you have specific security regulations you need to follow or specific rules, probably this will be the normal way to go.
have a very practical example. We've got a subscription, the VNet. It's totally not connected, so it's very, very secured, very private. But there is one service you need to call to get some reporting also in from it. So that's just done via a private endpoint. So
That's
you
the way to do it. Yep.
don't have to expose anything of that subscription to anybody, but you just allow that one single service to where you can get the information you need from it, and that's it.
Yep. So, but yeah, you should really, with some services, you also really need to get your IP addresses under control, because not everyone has the option to have a big VNet. And you see that a lot of customers, they're already popping up with all those subnets all filled up, or they make them too small or whatever. And then if you start up with private endpoints, yeah, they can be filled up and all your IP addresses can be gone quite quickly. So it's also a good idea if you start, like we said, if you start it up from the beginning and you start with the greenfield deployments, keep that one in mind. If you want to use them, maybe it's a good idea to foresee a separate subnet for them. So does anybody ask any other questions or something he wants to tell about his experience with Azure Private Endpoints or Private Link? So the thing I wanted to show in my portal before it completely dropped is this: if you want to use the VNet in combination, the Cloud Shell in combination with a VNet, it really creates a lot of resources. Like the relay, it's around 6-7 resources, I think. And if you start it up, I think it's almost 3-4, sometimes 5 minutes before it even starts up, and then you can use whatever SSH commands to use your Linux VMs or whatever. But it's really something they still need to do some work on. So you can try it out, but definitely don't do it on any production environment, because I think they're going to rearrange it that it will be easier to be deployed. To set it up, I had to use the Quickstar ARM templates. I had to use CLI, so it was a little bit of work to get it spinned up, but yeah, it's quite a fun way to work with your Linux VMs or Windows VMs directly from in the Cloud Shell. So I think we can say thank you now. Now I'm back. So